Hi everyone. So welcome to the Voxxed Days conference, and thank you for giving me an opportunity to speak. And I hope we have, because it's not a Scala and functional programming conference, so I believe there's a mix of people around here. So raise of hands, can I know how many of you are actually doing full-blown FP, as in like you're working on F#, OCaml, Haskell? Okay, anybody working on C#, Java? Okay, a lot of you guys, so a lot of friends here. Okay, so, and any of you are working on Scala? Okay, some of you, awesome, okay. Okay, so today's topic is composing effects with monads. I mean, my goal is not for you guys to walk out with a full understanding of monads, but I'm going to cover some of the basic functional programming stuff. So I want to evangelize functional programming because I think it's a solid art that is kind of lost its glamour because there's so much else to look at, machine learning and blockchain and all that stuff. So I've been doing FP for a while now, so about a couple of years. So Scala for a year and more. So it was in Scala that I saw the full power of doing FP, purely Haskell style. So I've done some bits and pieces in C#, but it was in Scala then when I saw that FP is actually really cool. Setting an expectation for the audience, right? So I hope that you guys have done Java 8 and you are like kind of familiar with, for example, high order program functions, right? And maybe optionals if you guys have used optionals, right? Java 8, okay. So that's effects. So I'm going to cover some of the basic stuff and then move over to monads. So I'm going to cover set a foundation so that we both are in the same page. So why monads, right? Why not any other topic? So one of the things is like eventually we'll come to a point where we need to have an understanding of monads, because if you are doing C#, you're probably writing a link queries and you'll be using sequence monad. If you're doing Java, you'll probably be doing completable future and you'll be hitting monads. So I think having an understanding of monads is and what kind of a monad you're using is pretty helpful in actually in your journey of functional programming. So this is the structure of the talk. So I'm going to have, because it's a quickie talk, I'm going to try to cover the basic stuff in a fast pace, so both of us are in a same level. I'm going to present a case study. So any one of you here who's not a Marvels fan? Who's not a Marvels fan? Okay, so everybody is a Marvels fan, so it's awesome. So I have a Marvel case study where you can relate to it, so how we can apply monads to solve this problem. So we'll see the problem can be solved in different ways. So we'll look at pattern matching solution. Java doesn't have pattern matching, so I'll try to cover how we can do it in Java. And because I'm going to use the Scala, so there's going to be slightly higher cognitive load on your head, but I think the number of features that I've used is really small. So I think if you know Java, C#, I think you should be kind of okay. Okay, so I think you kind of know what I'm going to talk. So if you are in a wrong room, right, so you just entered and you think the FP is not fun for you, it's your call to actually, if you want to go out, I'm really fine. So, yeah. So let's talk about how we do stuff in imperative programming, right? So when we do object-oriented programming, we can follow a lot of principles of FP, but I'm going to talk about an over stuff that typically we have used or probably doing today as well, right? So this is a case study where we'll have, for example, in Singapore, probably there's more inflation and HR decides to actually give hike to the employees. And it's a fictitious HR, right? So I don't know if your HR will give you 10% hike in a year. So so you have basically this is how I'll do in an object-oriented programming or imperative programming. So I have, so let's compare and contrast, right? So what is object-oriented programming? So you have these objects that muddle the data and the methods together, right? They basically combine them. That's called object. So they do mutation, right? So there you can see that employee is our object, which has the region, and then it has a salary, which is mutated by a method called risepay. So I have to care about synchronization because I'm having the state, and I want to make sure that whoever mutates it's thread safe. You could not take care of thread safety and actually use worker queues or maybe actors. So the point is, if you look at how the actual mutation happens, right? How we actually give the hike to the employees is basically via statements, right? So these are not expressions. So you basically tell the computer how you want to do things. So I'm going to loop over a method which gives me a list of employees, and I'll check if the region is Singapore, and then I will call a risepay of the employee object, right? So it's a mutation in place. So I hope so far you are with me. So now we move on to a FP approach of doing this, right? So in FP, we separate the data and the functions out. So this is actually at the very first step, we are orthogonal to how we do in object-oriented programming. So risepay is a function which takes an object and it doesn't actually mutate in place. It is immutable, the object is immutable, hence it creates a new object with the desired functionality, right? So it updates the salary, so it's a copy method. So there is no need to encapsulate a state because we are not holding it, right? So data is given, there's a data transformation that happens. So I want you to take a look at higher order functions, right? So filter and the map is a higher order function. So filter is taking a lambda, and I'm giving the filter that it should be Singapore, and then map is a functor. So functor is basically a design pattern where if you want to transform the data, you pass in a lambda that you want to transfer, and then you apply it on the functor. For example, here it's a sequence which is a functor. So you could have optional in Java or nullable in C#. Though C# nullable is not a functor, but yeah, it could have been made functor. There's a little bit about the effect type. So when you do functional programming, you will invariably come across people talking about effects. So an effect is nothing but, option is one of the examples of effect. An effect is a type that wraps another type and adds metadata to the type. For instance, option adds the metadata that the value may be present or may not be present, right? So a future adds a metadata that there's a possibility that the data may pass or fail, or it's available in the future point in time. The same way promises. So anybody who's a JavaScript developer? Okay, so the promises are monads. Anyone who's observables, reactive extensions? All right, so reactive extensions also has flat map, right? So they are monads and they are higher order type, right? So if you look at how do you understand effects, right? So these are higher order types. So just like higher order functions which take another function as an input, and higher order type basically takes another type as an input. So for instance, the list is a type of order 1. It takes a type of order 0 as input. For example, list of string is basically taking a string which is an order 0. So list is an order 1. An option of string is an order 1. An IO of string is an order 1. So now we go to another level, which is a type which takes a type which takes a type. It's kind of inception. That's basically functors. So higher content types is actually available in very few languages like Scala and Haskell. I'll probably not get into these details, but I think you kind of get the details, I guess. So we established the fundamental differences between objects and functions, and So if I have to write bigger programs in object-oriented programming, I'll probably have objects communicating with each other. If I have to do the same stuff in FP, I'll probably break down the solution into multiple smaller functions and then fuse them all together. That's called composition, right? So you can compare it to jigsaw, where a jigsaw piece is a function and the edges of the jigsaw are basically effect types. For example, if a function is returning an option or an IO, the effect types becomes your fusion point with another jigsaw piece. So before we move on to the Monads case study, right? So I want to establish the importance of composition in functional programming. So if I have to, we all have written parsers at some point in our lives, right? So if I have to write a CSV parser in functional programming, so it's as easy as you have seen till now, basically breaking down the solution into multiple smaller solutions and then fusing them together. So what is a CSV value, right? So it's basically any number of characters between two commas, right? So I have, if I have to write a CSV value, I have to write a parser for a single character. Then I have to write a parser for sequence of characters. Then it's basically any value between two commas. So I have to write a parser for except for comma itself. So I have to write a combinator for except. So basically, by doing that, what you have in the end is a triangle. Means basically you have a combinators at the bottom, and then you have pieces at the top where you can build applications. So if I have to build an XML parser tomorrow, I already have a character parser, a sequence parser. So all this at the bottom is already taken care for you. All you have to write is the XML elements at the top. So it's called monadic parser. If probably some of you are already familiar. So I'm building that on my own. It's just for fun project, but you will find implementations online. So it's probably the fun project to actually work on if you want to crack on FP and learn the really composition stuff. So now we come to the distraction part. So what we want to do is we want to solve this case study where everybody knows Iron Man. So most of you guys know Iron Man, right? So what happens is you suit up, then Iron Man engine starts and he launches. So if you think about it, it's a language agnostic modules. So it's not conforming to any language. So I have three modules, and each of them have different APIs or function calls. My objective at the end is I need to assemble the parts first. So when he does that, basically the iron suits him, and then I fuel him, and then he suit up, as in like I need to give Tony Stark, and then I have an Iron Man. Then I have to do engine start and launching, right? So there are some pre-checks and range verification before it takes off. So what are monads? Let's actually have a definition of monads so that in the end, when you actually learn how this all fits in, how the explanation fits in, that it actually is like this. So monads are basically abstractions, or it's an higher order type by itself, is used to sequence effectful dependent computation. So it's a mouthful, right? So if I take out dependent in this line, I can already use applicative functors. So it's very important that we have this full definition. So all I'm trying to say is, if you have a task where you have to do one step, and you have to do another step, and you have to do another step, then, and each of those steps actually return a type, which is like an option of something, right? And type of order 1 or higher, that's when you use monads. And now, typical object-oriented programmers that I have interacted with when I give presentation, they're like, what's so cool about it, right? So we do that thing all the time in object-oriented programming, do that, after this you do this, right? So, but we saw that in our example when we gave hike to the employees. In FP, we want to write expressions. So an expression is about what you want to do, not how you want to do, and it always returns a value. So there is a value in actually writing an expression of how to do it. So that is happening by composing the functions and then using the monads to do it. So they're basically binding the functions which return effects. So this is Scala code. I hope you are fine with that. So the pseudocode that I wrote is actually listed down in Scala code. So suit up is basically assemble parts, fuel, and suit up, right? So suit up, I get the iron suit already after fueling, and I put Tony Stark inside, then I get Iron Man. So the point here is they are dependent computations. It has to happen one after another. Then I have two other modules that we discussed. So pre-launch check basically takes Iron Man, and then it basically returns and does some mutation side effects on the Iron Man. So can anyone tell me why are these types returning? Why are they returning option? Yeah, absolutely. So the thing can fail, right? So I have choose it as an option, the effect type, but you could choose other types. Normally, when I write code in production using Scala, I use an IO type, but for simplicity, I've used the option type here. So let's solve the problem, right? So all we have to do is just fuse all these API calls together and then launch him. So how do we do it with a plain vanilla functional calls, right? So this is how our API looks if you look at it, right? So first API returns a structure which is f of a. So f is nothing but an option. Second API takes the output of the first API, whatever is inside that f of a, it takes an a and then does something and gives a new output. So why does the functional composition doesn't work? Can you make any judgments, or why do you think it won't compile? Why do you think this one won't compile, or maybe actual API calls? So if I call fuel and call the assemble inside the fuel, right? It's a functional call. So why it won't compile? Anybody can make a. So the first call is returning an option of iron suit, and I want an iron suit, and I basically fuel that up and return the iron suit which is fueled. Any guesses? Yes, it's a type. It's a basic stuff, right? Type mismatch. This is the problem that Monads solve. So the fuel is expecting not an option of iron suit. It's expecting iron suit, right? So the actual vanilla functional call don't work. So let's see how we do in Java, right? So I do the first API call, assembling the parts, and then I check the output if an option is defined, whether I have value inside it, and then I call the next API call. So I keep doing that with all the API calls that I have to finally launch him. So pattern matching is really same as the if conditions that we did, right? So Scala has pattern matching, so I wouldn't use an if condition. So I would basically, the output is an option. If an option is either a sum or a none. Sum means I have the value, means the call was successful. So this is what happens, right? So this is the full call. If I have to follow this approach of pattern matching or an if condition, I would end up with this mess. It's an arrow, right? So you can see that there is a pattern emerging out of this. And the pattern is, if you have a value, call the next API. If you don't have a value, return none. So when we say don't repeat yourself, I think without monads, we'll end up actually repeating a lot of code. So let's look at how we solve functor way, right? So remember, when we gave hike to the employees, we did a map and called the increase pay. That's a functor. Basically, it takes an option type, for example, and then it applies a function which transforms the value inside. So I understand that you may have cognitive load in terms of the syntax, but let me try and explain here, right? So this is the basic type parameters, A and B. So I get a first option of A, and you can substitute for an F, you can substitute as an option, and then I get a mapping function to map whatever value inside. It's a pure function mapper, right? So I'm defining a map for an option. So when I basically pattern match the first one, if it has a value, then apply the mapper and wrap that inside an option, because I need to return an option of B. So if you have to do it in Java, how I write the map is basically if is defined, then you apply the function. So if I do it the functor way, let me explain you the map function, right? So this, I think the diagram speaks 1,000 words. So if you look at the circle, it's the value inside the computation. So what is an effect? Effect is basically, it is speaks about the computation, whether it can pass or fail. It's a computation metadata. So I have a transformer which basically transforms a circle into a triangle. So a map basically transforms whatever is there inside, but retains the outer structure. It's a structure preserving thing. So now, if you look at our actual Ironman APIs, they are not actually of this type. Look at the mapper, right? They are actually, because fueling actually returns an option, iron suit inside an option. So our APIs are like this, means they can fail themselves. The next API can fail. So what happens with the functor is, if you use functors for that, for fusing the APIs, you will solve the jigsaw puzzle, but it will be in this box, an option of option of option of option inside that, right? So this is where people actually don't get monads. So you look at online tutorials, right? A lot of people start talking about the machinery of monads, how flat map will box and unbox. But end of it, what are we trying to do? We are basically trying to fuse the functions which are dependent and the return effect, right? That's basically it. Sequencing dependent computation. So we should not lose sight of what we want to do. So what we want to do is basically every time a map functor is called, it's adding a layer around the type. Can we have some kind of a flattener? Basically, if it adds a box within a box, maybe we'll take out the outer box. So we have a flatten method. All it takes is option within an option, and it will basically unwrap this outer layer. So if you don't get the code, don't worry, but if you understand the concept in terms of the figure, you can see that flatten takes the two layers and take out the outer layer, right? So we are able to fit the jigsaw puzzle here. So that's it really. That is monad. Monad is nothing but a combination of map followed by flatten. So that is expressed as flat map. So it takes an option, and the second API is again a thing that can fail, and basically pattern matches. If the value is there, then it just applies the function without actually wrapping it again. So that is a flat map. So that's a definition of flat map for an option. So if you have a monads for example, sequence, list, the definition would be different. So now, if I start applying that flat map to our original APIs, this is how it looks. So I call the API, assemble parts, and then flat map and call the next API, and flat map call the next API. What will happen is I'll get an Iron Man. This is just a suit up. So if I do the complete API, this is how it looks, right? So this is called a for comprehension. So instead of a flat map, I'm using a syntactic compiler sugar that's available in most of the languages which support monads, right? For example, Scala has for comprehension, and Haskell has do notations. F# has some kind of a comprehension as well. I think list comprehensions for the list monads. So if you look at it, really the nesting of lambdas is the functional way of saying that you call this callback later. It's really a callback way of saying that you call me the next API in the line is basically in the callback, and you're doing some kind of a flattening. So that itself is a monad, that's all. So do you have any questions at this point? So the whole API solution actually fits it in just a few lines of code. Whereas if I have to do a non-functional way, I'll have to do an if condition and write the whole code, right? We saw that duplicated code. So really, monads enjoy a lot of attention in functional programming for interactive programming and composing functions. So really they are simple. I've recently seen a TED talk where they gave a statistics about the business. So 90% of the businesses actually looks like they fail first time, and 90% of them actually don't try a second try. and 80% of the people who actually try it second time actually succeed. So I am urging you guys to actually give it a try. So because a lot of object-oriented languages today have functional features, right? So take Kotlin, so it's a full-fledged language features like abstract data, algebraic data types, sum types, and none types. Java is going to get it as well, but I think Java has its own verbosity regardless of Java 8. But I think you can still write functional code. Don't write statements like for loops. Use filters and try to write more expressive code. So we can actually move gradually from more imperative style to more functional style. So these are the references that I did while learning functional programming. This is one of the best books you can read, Scala Red Book. The only issue with that book is it's a little hard read because that book is written for people who want to actually develop functional frameworks, the purely functional programming. So there is a subtle difference between a functional programming and purely functional programming. I would like to talk about that. So initially when I actually designed this talk, right, so it was a talk at the company where I talk about the IO monads and laziness and all that, and a lot of people did not get it. That's when I decided that it was because it was just my team doing all this stuff. So I've decided that we should actually do more basic stuff, actually evangelize these things so that more people can catch up with FP and we can have more bigger community. So this one, Red Book, is about purely functional programming, but it will cover a lot of the things that I spoke today and a lot of the things that you will see. It's one of the best books you can read. It's an investment. It's a slow read though. If you are into Scala, cats with underscore is amazing. Cats is a functional library in Scala, so that's what we are using for purely functional programming. Programming in Scala, Haskell Hutton is very good as well. And Haskell book is very, very big book, but I've read parts of the book. It's pretty good as well. So that's it really. So is there any questions that you guys have that I can take? Okay. Do you guys get it? All right, thanks a lot, guys. Thank you for the time.